Hi everyone, welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about tuned amplifiers. So why tuned circuit is needed in electronic circuits? So let's discuss the need of tuned circuits. So generally in amplifiers we need to improve the signal level of the weak signal. So but when we are using the tuned circuit in amplifiers, it selects a particular frequency and it amplifies that signal. So in those applications tuned circuit is used, and also the bandwidth can be adjusted through various tuned circuits. So we use resonance concept for tuned circuits. And what is mean by tuned amplifiers? Let's define the tuned amplifiers. So amplifier circuit in which the load is a tank circuit. So it is tuned or pause or amplify the selection of a desired frequency, because here we have a common emitter amplifier circuit in which the input signal is given to the base of the amplifier, and at the collector terminal load is connected as a tank circuit in which RLC circuit is connected. So this is the tank circuit. So this circuit is used to select a desired frequency. It will reject the all other frequencies. So this is the concept of tuned amplifiers. And what is the resonant frequency in the tuned amplifiers? So it is the uh, 1 by 2 pi root LC, where L and C are the inductance and capacitance values. So in which we are using the tank circuit. And this is the circuit diagram for tuned amplifier, which acts as the tuned amplifier for single tuned amplifiers. So here we have an input signal applied at the base of the transistor, and remaining circuit R1 R2 is the voltage divider biasing. It is used to bias the transistor in the active region, and at the collector of the amplifier we have the tuned circuit. So this circuit select a particular frequency based on the resonant frequency of this tuned circuit, and Re is the emitter resistance, Ce is the emitter capacitance, also known as bypass capacitance. So this circuit acts as a tuned amplifier. And in which tuned circuit, here the inductive reactance become equal to capacitive reactance. This phenomenon is called as the resonance. Then the circuit behaves as a resistive circuit, and the corresponding frequency of this tuned circuit is the resonant frequency. Here it is the parallel resonant circuit. And what are the classification of tuned amplifiers? So generally we have single tuned amplifiers, double tuned amplifiers, and stagger tuned amplifiers, and also neutralized amplifier and class C amplifier. So basically we use three circuits: single tune, double tune, and stagger tune. And what is the difference between this is, single tuned uses uh, only one tank circuit, and double tune we use two coupled circuits, two tank circuits for the wider bandwidth and also great selectivity. And stagger tuned achieves wider bandwidth with multiple stages of tuned circuit. And what are the characteristics of tuned amplifiers? So frequency selectivity, because of selection of tank circuit for particularly choosing the desired frequency while rejecting all other frequencies, and also gain, stability, noise figure, and bandwidth. So these are the characteristics of tuned amplifiers. So bandwidth can be varied, depends on these double tuned or stagger tuned circuit. And operation of tuned amplifiers. So first of all we need to give an input signal containing a range of frequencies. So this input signal is applied to the transistor amplifier, and L and C circuit acts as a tuned circuit resonance. And impedance at the resonance, at the resonant frequency impedance is maximum, so it amplifies the signal, and using the resonant frequency due to the high impedance load. And frequency response, here the parallel resonance occurs at frequency of FR, in which the circuit has a high quality factor. So a quality factor is this defines the selectivity of the circuit. So here at a particular frequency the gain is maximum, so it quality factor is also high. And these are the advantages of the circuit: high gain, frequency selectivity, noise reduction and versatility. And disadvantages are narrow bandwidth, stability issues, tuning and complexity. And applications are radio receivers, transmitter, IF amplifiers, oscillators, spectrum analyzers and wireless systems. And assessment questions: what is the main advantage of using tuned amplifier over an untuned amplifier in RF application? So the answer is frequency selectivity and rejection of unwanted signals. And what component is typically used in collector load of tuned amplifier? So the answer is tuned LC circuit. So thank you for listening this lecture.